Hello friends, in this class we are going to discuss example for DAG representation of basic block. Welcome back here, and the next topic is DAG for the basic block. So we have already seen this the directed acyclic graph for the expression. Okay, so we have already seen DAG for expression, and the idea was using DAG for the expression was to uh, compute common expression only once. Okay, so compute common expression only once. So now that help also to minimize the number of temporary variables that we generate. Now the same concept is applied for the entire block. Okay, and this is our basic block. Okay, so this is our basic block, and that we want to create a DAG for it. Okay, so this can be created in the same manner as we have done that here. We have a reading of B and C, and we have already seen that how to create it, and the root node is plus. So I will create here plus, and I will write here B, and I'll write here C. Okay, and I label this node as A. Next is your A minus D, and here we have to look at the latest value of A. Latest value of A. So here in this case we want A. So this is the latest value of A, then minus, and then we have a definition of D with us. And let's call this label as B. Then C is equal to B plus C, and this is the latest value of B. And just we will take this value, latest value, and we will put here a plus, and the C will take from this place and look like this. The last one is D is equal to A minus D, but you notice here that A and D is the latest value is same, and the same label I can put here as D. Okay, so now this is the DAG for the basic block. Okay, so this we call it as a DAG for the basic block. You notice here that we have only three nodes present over here. Three nodes present over here at root. Three let's say non-leaf node, non-leaf node. Okay, so let me read out few things here. It might appear that since there are only three non-leaf nodes in the DAG, the basic block can be represented by a block with only three statement. Okay, so because there's only three nodes are there, we can represent this basic block by using only three statements. So that is, now we are coming into the analysis part. Only three statements are enough to represent the basic block. Then it says that in fact if, okay, now it is the condition, in fact if B is not alive on the exit from the block. Okay, now this statement is making that if B is not alive, and then we have to check the liveness analysis. But if in cases B is not alive, B is not alive, if it is the case that it is not alive, not alive, sorry, not live on the exit of the block, we don't need to compute that variable, and can use D to receive the value presented by the node labeled in the figure. The block becomes this. Okay, so a hypothetical situation it is talking about that if D is not alive, then A is equal to B plus C, it is okay. Since D is not alive, I can assign the value D over here, and it becomes A minus D, and I can replace C here. C is equal to B plus C, so that I can write here D plus C. So it's a hypothetical situation that if it is there, but since we haven't learned anything about the liveness analysis, we haven't done anything like this. So we are not sure, but if it is the case, if it is the case, we can represent in the fewer number of fewer number of instructions. That's how we can create a DAG for the block. Okay, so that's all for this. Thank you.